So in this series of problems of alternating current, today we have another problem here. It is given 200 ohm resistor and a capacitor of 15 microfarad. They are connected in series here with a 220 volt source, and frequency of the source is 50 hertz. We have to calculate here what is the value of current in the circuit. That is the first part. And the second part, we have to calculate RMS voltage across the resistor and across this capacitor. Here in the question it is mistake, it is not the inductor, it is the capacitor here. And also we have to, is this the algebraic sum of this voltage more than the source voltage, right? If yes, resolve the paradox. Means we'll calculate the RMS voltage across the resistor, we'll calculate the RMS voltage across the capacitor, and afterwards what we'll do, we'll add these two voltages, right? We'll do the algebraic addition and we'll find out whether these two algebraic addition of these two RMS voltages across the resistor and the capacitor, it is coming out to be same or it is coming out to be different, right? So let's solve this problem. So first we have to calculate the current in the circuit. So for calculation of current in the circuit, of course first we'll try to calculate what is the impedance of this circuit, right? And before calculating the impedance, we'll try to write expression for resistor and the capacitor, right, into the phasor method, into the complex number form, right? So we'll write here R phasor, R phasor. As we are writing R phasor, we can write as R only, so which is nothing but 200 ohm, right? R phasor is 200 ohm here, and capacitance is given 15 microfarad. So we'll calculate here XC phasor, and we know XC phasor we are writing as XC angle of minus pi by 2, XC angle of minus pi by 2, or also we can write minus JXC, right? So we'll calculate here what is the value of XC. XC we can write as 1 divided by C omega, 1 by C omega. So that is equal to 1 divided by capacitance. Capacitance is how much? It is 15 microfarad. So we can write here 15 into 10 to the power minus 6, right, into omega. Now if you see in the problem here, 50 hertz is given, 50 hertz, that means the frequency is given, here, frequency of the source is 50 hertz, 50 hertz, right? So omega we can calculate, we know omega is equal to 2 pi f, 2 pi f, right? So that is equal to 2 pi into frequency, which is 50 hertz, 50, so that becomes 50 into 2 pi, that is 100 pi. So frequency is 100 pi, sorry, frequency, not frequency, frequency is already given, it is omega, right? It is, this is the omega, right? So omega is 100 pi, 100 pi radian per second. This is the omega, right? Now we'll calculate here the value of XC. So XC is 1 by C omega. So 1 by C omega, C already we have written, 15 into 10 to the power minus 6, right? Microfarad it is, so we have converted this into farad. उसके बाद हम क्या करेंगे, ओमेगा लिखेंगे. ओमेगा is 100 pi. So 100 pi already we have calculated. Now we'll calculate the value of this. So if you calculate this value, 1 divided by 15 into 10 to the power minus 6 into 100 pi, the value it is going to come, it is 212 ohm, 212 ohm. This is the value. That means XC is equal to 212 ohm. XC is equal to 212 ohm, 212 ohm, right? So this is the value of XC. Now for calculation of what we do, we have to calculate the current, right? So first we'll try to calculate the impedance of the circuit. So we'll write here Z phasor, you can write as R phasor plus XC phasor, right? So R phasor R phasor here is R, which is 200 plus XC phasor. XC phasor already we know how to write, it is minus JXC. So that is minus JXC, right? Minus JXC, so that will be equal to 200 minus J cap into XC. Already we have calculated, XC is 212, right? So basically Z phasor, mod of Z phasor आप क्या लिखोगे? Mod of Z, that is the impedance, that is under root of, because it is in the vector form, right? It is in the complex number form, so that is under root of 200 का स्क्वायर आप लिखोगे, 200 का स्क्वायर प्लस 212 का स्क्वायर, right? सो अगर आप इसे कैलकुलेट करोगे, तो ये आपका कुछ आएगा 291.5 ओम। सो इम्पिडेंस ऑफ द सर्किट इज 291.5 ओम, इसकी वैल्यू आ गई। और हमें क्या कैलकुलेट करना है, हमें कैलकुलेट करना है करंट। सो current calculate करना। So actually they have just asked the current, that means we have to calculate basically the IRMS, right? And the voltage which is given here 220 volt, that 220 volt, it will be actually VRMS. So VRMS is given here into the problem। VRMS क्वेश्चन में दिया हुआ है, VRMS की वैल्यू है 220 वोल्ट, 220 वोल्ट, 220 वोल्ट। सो विल कैलकुलेट हियर IRMS। सो IRMS आप लिखोगे, IRMS is equal to VRMS divided by mod of Z, that is the impedance। So VRMS की वैल्यू है 220 वोल्ट divided by mod of Z, impedance is 291.5, 291.5। अगर आप इसे कैलकुलेट करोगे तो ये कुछ इसकी वैल्यू होगी 0.755 एम्पेयर। तो ये तो हमारा पहला आंसर हुआ, दैट इज द IRMS is 0.755 ampere। Now the second part is very interesting। It is given, calculate the voltage VRMS across the resistor and the inductor। It is not inductor, it is actually capacitor। So basically we have to calculate the RMS voltage across the resistor and the capacitor। So we'll calculate here। So first we'll calculate VRMS across resistor, that can be written as IRMS into resistor, IRMS into resistance, right? So you can write like this। So IRMS we have already calculated here, 0.755, 0.755 into resistance, resistance is how much? It is 200, so that is 200, so into 200, right? So if you calculate this, अगर आप इसे calculate करेंगे तो ये कुछ आएगा 151 volt, that is 151 volt, right? Now we'll calculate VRMS across capacitor, and that can be written as IRMS into capacitive reactance XC। So IRMS is 0.755 into capacitive reactance XC also we have calculated here। XC की वैल्यू कितनी है? 212 ओम, here 212 ohm it is। So 212 and that is equal to 160 volt, right? So VRMS की वैल्यू जो आ गई 151 वोल्ट है और VRMS अक्रॉस कैपेसिटर की वैल्यू है 160 वोल्ट। अब इस क्वेश्चन का जो सबसे लास्ट पार्ट है, if you just observe here, into this it is given, is the algebraic sum of these voltage more than the source voltage? If yes, resolve the paradox। So we have to find here is the algebraic sum of, so if you do the algebraic addition, so if you add here VRMS resistance plus VRMS across the capacitor, if you add these two voltages, right, simple algebraic addition, so it is 151 plus 160, and which will be equal to, this is 165, 112 and 311 volt, so it is 311 volt। So clearly it is 311 volt, which is different than this, the voltage of source, right? And why it is different? Actually, the reason being, the voltage across the resistor and the voltage across the capacitor, these two voltages are not in the same phase, because we know across the resistor the current and the voltage both remains the same phase, but across the capacitor the current leads the voltage by phase of pi by 2, right? So voltage across the resistor and the voltage across the capacitor are not in the same phase here, there will be phase difference of pi by 2, right? That is the reason being this result is not the simple algebraic addition। So what we have to do here, actually we have to do the vector addition, right? So for example, let's say this is the current phasor, here, this is the current phasor, and we know voltage across the resistance will be in the direction of current, right? So you can say this is VR also, VR phasor, right? So this is the current phasor as well as the VR phasor, because we know in across the resistor current and voltage both remains in the same phase। So अब आप क्या करोगे, अब आप कैपेसिटर के लिए ड्रॉ करोगे। सो हमें पता है कि अक्रॉस द कैपेसिटर करंट लीड्स द वोल्टेज, करंट लीड करता है, राइट? दैट मींस वोल्टेज लैग्स। सो वोल्टेज को आप लैग करा दो, सो वोल्टेज लैग्स बाय 2 हियर, So this is the VC. This is the VC. So using the concept of vector addition, right? So what we do here, this is the VC, and this is the net voltage. This is the net voltage. This is the net voltage V net. V net. So V net, अगर आप V net कैलकुलेट करोगे, so V net is equal to अंडर रूट ऑफ वी आर स्क्वायर प्लस वी सी का स्क्वायर, वी आर स्क्वायर प्लस वी सी का स्क्वायर. So that can be written as under root of VR. VR is how much? VR is voltage RMS across resistance is 151. So 151 का square, right? Plus VC. VC is the voltage across the capacitor, and that is 160. So 160 का square. If you add these two, the result will be 220 volt, right? So this is the how we add the two voltages. We have to take care of phase also, because it is not the simple algebraic addition, right? So we have to take care of phase difference also here, and we know here the resistor, the voltage across the resistor and the voltage across the capacitor, both are not in the same phase. Thank you.